There is another way of approaching these type, and this is to turn it from trig to pronumerals. Or probably more correct to say polynomial. Actually, it turns out to be a quadratic. If we use t results to solve the equation instead, same equation, but now I'm going to say I'm going to let t equal tan theta on 2. My equation now becomes this. 3 outside of 1 minus t squared and 1 plus t squared, plus 4 outside of 2t and 1 plus t squared is 2. But now I'm only looking for answers going in between 0 and 180. Because I'm finding answers for theta on 2. Well, get rid of the denominators, multiply both sides by 1 plus t squared, pull it all together, there's the quadratic I have to solve. It doesn't work out nice and neat, so I go to the quadratic formula. I now know tan theta on 2 is either 4 minus root 21 on 5 or 4 plus root 21 on 5. I guess the most difficult thing about this is working out whether it's positive or negative. But the nice thing about this is because I'm only looking for things in either the first or second quadrants, and I know tan is positive in the first quadrant, tan is negative in the second quadrant, so if that's negative, which I think the first one is, isn't it? Yeah, 4 minus root 21, I know I've got an obtuse angle there, and the second one I should say, and the second one has to be the acute angle answer. So that one's quadrant 2. I mean, I've just made it positive by swapping it around to work out what the equivalent acute angle would be, but it's the obtuse angle that I'm after, so 173.21 multiplied by 2, and there's our answer, 346.42. Now we go to the other one, which must be in the first quadrant, 59.47. Double it, 119.33, and there's the two answers we got before. However, this method does have an issue. If it turns out the answer is 180 degrees, we got a problem, because that means I'm subbing in 180 divided by 2, which is 90, and we can't find the tan of 90. So this method will never find that solution. So you always need to check. And it's pretty easy to check because the cosine of 180 is, okay, and the sine of 180 is, therefore really you're just looking at the coefficient of the cosine function. Is negative 3 equal to 2? No, it's not. So 180 is not a solution. But make sure you test that if you're using this method. Okay.